Assalamualaikum warahmatullahi ta'ala wabarakatuh. We are going to continue with the chapter on maintenance and re-engineering. Okay, so first we will see maintenance, then we will see re-engineering. So what is maintenance? What is software maintenance? So when we talk about software maintenance, before we do software maintenance, actually the software is released to the user. Okay, that is a condition of software maintenance. So software is released to end user, and when the software is released to end user, within this you will see bugs of report, filter back. Okay, you will see bugs of report. So then you have to filter the bugs of report. Then within a week, one class of user indicates that the software must be changed so that it can accommodate the special needs of the environment, meaning you have to do changes. Then, within months, another corporate group who wanted nothing to do with the software when it was released now recognized that it may provide them with unexpected benefits. They will need a few enhancements. This is also software maintenance. You have to repair the bugs. Okay, you have to do some changes to accommodate the needs. You have to do enhancement. Plus, you have to do the defect correction. You have to correct the defect. You have to extend the function. You do patching. You do fixing. So all of these are part of software maintenance. Okay, and in order to do the software maintenance, the software must be maintainable. So we need to see what is maintainable software. So maintainable software basically is the software that exhibits effective modularity. We look what is modularity over here. Okay, modularity basically is a breaking down a software into multiple modules. Meaning when you have a project, when you have a software project, you do not develop the project as a one module. Meaning you will separate it, you break it into multiple module which will be developed separately. So it is the maintenance. Okay, it's easier for you to maintain the module itself, which you only do maintenance on specific module when it needed. Then it made design patents. It made use of design patents that allow ease of understanding. Okay, you have to refer to the design when you do maintenance of the software. It has been constructed well-defined, coding standard and conventions, leading to source code that is self-documenting and understandable. Meaning when someone coding, it's follow the standard and convention of coding. It has note, it has command, so that actually it's lead to self-documentation which helped others to read and to understand it. Okay, it has undergone variety of quality assurance techniques that have uncovered potential maintenance problem before the software is released. Meaning this is a proactive event, which is we try to identify potential maintenance problem. So when it happens, easier for us to do the maintenance. It has been created by software engineers who recognize that they may not be around when changes must be made. Because in the software project, perhaps the person who actually in the part of software engineering might not be there for the whole time, for the lifetime of the product. So that when maintenance is need to be done, so this is the most, this is one of the important things that you need to consider. Therefore, the design and implementation of the software must assist the person who is making the changes. Okay, so that is maintainable software. So beside maintainable software, there is another word, which is supportability. So when we talk about maintenance is about correction, adaptation, enhancement. That is maintenance. How about supportability? What is supportability? Okay, so when we talk about supportability is capability of supporting software over its whole product life, because every software it has its own product life. How long? Okay, the time that the software should serve the user. So, which is this portability actually considered during analysis and design phase, which it is supporting ongoing operational of the product of the software. It has end user support and it support re-engineering activities. Okay, so these are the things that supportability should do. All right. Software supportability, the definition, actually it is the capability of supporting a software system over its whole product life. Okay, so a software should contain facilities to assist support personnel when a defect is encountered in an operational environment. Support personnel should have access to database contain records of all defects that have already been encountered. Meaning, if the errors is encountered, then the person should have the access to the database. So they may see the characteristics, they may see the cores, and they may see how it's cured. So then it's easier and faster to do support. Okay, this is an example of software supportability plan. You will see the macros windows actually. So starting from the last cycle date is 2012, it should support until 2023. Okay, this is what does it mean by this supportability software support is considered during analysis and design phase. All right. So let's see to our next slide, re-engineering. When we talk about re-engineering, we have for business process. Okay, so business process actually is a set of logical related tasks performed to achieve defined business outcome. Okay, so business process actually is part of re-engineering, which is related to the IT system and also related to the software application. So let's see here. Re-engineering. Okay, when we talk about maintenance, okay, let's see the scenario. We have outdated processes which need to be re-engineered. When it's supposed to be re-engineered, okay, let's see. You have a software, okay, you use the software regularly, okay. What happens is that the systems might break, okay, and then you keep repairing, you do fixing, you do patching, you extend the functionality. That's the thing that you do in the maintenance. However, along the time, okay, the maintenance become increasingly difficult. Okay, meaning it takes time, it's costly. Okay, then it is a time for you to consider about re-engineering. So re-engineering is something that you do, okay, to build the software, okay, which that software actually has added functionality, better performance, reliable and maintainable. Okay, so that is re-engineering needed. Okay, when the software is not maintainable anymore, then you may do re-engineering. So that when you do re-engineering, you have to use the power of modern information technology, radically redesign business processes in order to achieve dramatic improvement in the performance. That's what you're doing in re-engineering. Okay, the next slide is about business process re-engineering. Okay, this is it has 6 activities, and these activities is iterative, is and also top-down approach. So we have a process definition. Okay, start with the business definition. You go to the process identification, and then straight away go to evaluation, then process specification and design, then prototype, and then refinement and installation. So this can be done iteratively. All right. So the next slide is on business process re-engineering. Okay, how the iterative is work. So first step is business definition. So when you have business definition, you actually identify the goals. Okay, the goal. Then the process will go to process identification. So actually this process is answering how to achieve the goal. Okay, then it will go to process evaluation. This process evaluation will analyze existing process and identify the ideal process to achieve the goal. Okay, then it goes to process specification and design. So process specification design will come out with use case, which this use case actually gather from the information that you have from the definition, from the identification, and from the evaluation. Using these 3 informations, then use case is developed, and this use case will be used to develop a prototype. And then the prototype will be tested, and you will have to do refinement and installation. So, and this is maybe done iteratively. Okay? That is business process reengineering. All right. So then this is the definition for each of the business process reengineering that you see just now, which is business definition. What is the goals? Identify within the context of the key drivers, which is the cost reduction, time reduction, quality improvement, personal development, and empowerment. So this is the one we talk about the goal. Okay. Then what we have here is that process identification, process that are critical to achieving the goal defined in the process identified. Okay, and then process evaluation, you study the existing process thoroughly, analyze and measure it. Then process specification design is based on information obtained during the first three BPR activities, and then use keys are prepared for each process to be designed. This is the one. 1, 2, 3. So it leads to the use case. Then refinement in stage, then prototype. Okay, and then you do refinement and installation based on the feedback from prototype that this process is refined and instantiated within business system. So that is the explanation about the BPR. All right, so BPR has principles. So when you want to execute BPR, you have to consider all of these principles. Organize outcomes, not tasks. Okay, what is the outcome? Okay, have those who use the output of the process perform the process, meaning you need to make sure that actually the one that using it is perform the process. Incorporate information processing work into real work that produce the raw information. Treat geographically dispersed resources as though they were centralized. Link parallel activities instead of integrated their results when different. Put the decision point where the work is performed and build control into the process, and capture data once it's sourced. Alright, so then let's see. Software engineering. Before you start to rebuild, these are the 4 things that you have to consider. First is the reason for you to rebuild. Structure of the existing system. Is it weak or strong? How the original was built. Okay, built only using most modern and long-lasting materials. So these are the 4 things that you have to consider before you decide to rebuild. Okay, software engineering process model, there are 6 here, which is inventory analysis, document restructuring, reverse engineering, code restructuring, data restructuring, and forward engineering. Okay, let's see what is inventory analysis. Alright, inventory analysis is actually every software organization should have inventory application spreadsheets, okay, which record all of the necessary information about the application that they have in the organization. So that it will state what is the name of the application, year it was originally created, number of status changes, total effort applied, dust list, the date last, substantive change, and so on. What actually need to be done is analyze and prioritize to select candidate for re-engineering. Do not re-engineering everything, okay? You have to identify and prioritize. Inventory is revisited on regular basis. Okay, so you don't wait until everything goes wrong. Okay, all right. So for document restructuring, so the third one you have here is document restructuring. Second one is document restructuring. What is document restructuring? So document restructuring actually is referring to, let's see the document itself. Document for legacy system, they have quick documentation as a trademark. Okay, that is a trademark, right? So what do we do about it? What are our options? So basically there are 3 options here. Create documentation is far too time consuming and costly. If you create documentation, it is time consuming, it is costly. What you have to do, if the system works, we will live with what we have. Okay, let's say another option. Documentation must be updated, but we have limited resources. So what we do is that, meaning we don't have the previous document, for example, well, how to do it, okay? So what we may do is that we used a document when touched. It's meaning when you do changes and then you document the changes, okay? So that is what does it mean by document when we touch. It may not be necessary to fully redo command and applications, okay? Then the third option is that the system is business critical and must be fully re-documented. You see, meaning you have to redocument. Even in this case, an intelligent approach is to pair documents to an essential minimum, meaning whatever necessary, whatever important you documented. Yeah, okay, that is document structuring. Then we will see reverse engineering. Okay. So in reverse engineering, so what we have reverse engineering is here. Okay, software engineering, it's a process model. We have pre-engineering. Okay, so what is reverse engineering? So reverse engineering is a process of extracting knowledge or design information from any man-made and reproducing it based on extracted information. Okay? A process of recovering the design, requirement specification, and function of a product from an analysis of its code. It builds a program database and generate information from this. The purpose is of reverse engineering is to facilitate the maintenance by improving understandability of a system and produce necessary document for a legacy system. Okay, so that reverse engineering, actually you are studying the current code. Okay, so that you recover design, you recover a specification, you recover the functions. Okay, that is reverse engineering. Okay, what we have here is that the diagram for reverse engineering. So the explanation. Okay, all related activity mostly fall into two categories. Okay, which is software development related and software security related. Okay, two categories. Process of design discovery. This is discovery design process. Yeah, reverse engineering. Reverse engineering tools extract data, architecture, and procedural design of existing system. Extraction of sophistication of the design information can be extracted from source code. Okay, evaluate all program, meaning you evaluate the existing program. Okay, all right. So this is what they do. So there is a source code. Okay, you extract and understand the procedural specification of already existing document. Okay, so the main reason is for restructuring the code. Okay, when you want actually to do restructuring of the code, and then you extract abstraction. So it will extract three things, which is process, interface, and database. Okay, the designer or the engineer must evaluate primitive program and thereby source code and extract meaningful specification of process is to be performed, interface that is to be built, and database that is to be used. Okay, this is what it is doing here actually. Build an initial model listing and determining its candidate key to define the tentative classes, defining general design, and discovering association. This is done before you commencing re-engineering of the software. This is the definition of abstraction, yeah? I have mentioned about abstraction just now. Abstraction. So what is abstraction? Okay. Abstraction is the act of representing essential features without including the background detail or explanation. In the computer science and software engineering domain, abstraction principle is used to reduce complexity and allow design and implementation of complex software systems. That is the idea behind abstraction. Okay, code restructuring. Okay, what is code restructuring? Source code is analyzed using restructuring tools. Okay, poorly designed code segments are redesigned. Okay, violations of structured program construct are noted, and code is then restructured. Okay, The results on the structured code is reviewed and tested to ensure that anomalies have been introduced. Internal code documentation is updated. Okay, then we go to data restructuring. Okay, data restructuring in this slide is referred to internal data restructuring. Okay, so unlike that code restructuring, which occurs at a relatively low level of abstraction, okay, data restructuring is full-scale engineering activity because data is related to the whole software. Okay, so in most data restructuring begins with reverse engineering activity. So first, current data architecture is dissected and necessary data models are defined. Okay, and you see the data architecture. Okay, then data objects are identified and existing data structure are reviewed for quality. And then this is the second one. All of the object attributes are identified. When data structure is weak, okay, the data are engineered. Okay, so this is the important point because data architecture has a strong influence on program architecture and the algorithm that populate it. Changes to the data will invariably result either architectural or code level changes. Okay, this is the important part of data restructuring. Then we have, lastly, I'm going to share with you the forward engineering. Okay, forward engineering, okay, look at the scenario here, number 1 until number 8. Forward engineering, the cost to maintain one line of a source code may be 20 to 40 times the cost of initial development of that line, you see? Okay, higher cost, higher time, more time. Redesign of software architecture, okay, using modern design concept can greatly facilitate future maintenance. Okay. Because prototype of the software already exists, there is an existing system, so the prototype is there. Development productivity should be more higher than average. Okay, the user now has experience with the software, therefore new requirements and the direction of change can be ascertained with greater ease. Case tools for re-engineering will automate parts of the job and complete software configuration will exist upon preventive maintenance. That is the idea of forward engineering, meaning you have existing systems, which is to maintain one line is costly. You have prototype, meaning development activity must be higher than average, meaning it is faster. Okay, and we have user experience, which is certain. Okay, therefore new requirement direction of the change are ascertained with greater ease. So then we will do forward engineering to build a new system. So that's all for this chapter. Thank you.